So this is the first question we are going to discuss. I will not be reading out the questions, but I'll ask you to pause the video and have a read yourself while I point the important points in this particular question. So this question is all about horizontal pod autoscaler, or HPA, pretty much creating an object in Kubernetes called horizontal pod autoscaler. That's this question is all about. So at the end of the day, all you need to do is to create a YAML file with this particular object, fill up the values which they have mentioned here, and then execute the command kubectl apply -f, then the YAML file. In fact, that's the format we will be following throughout the course. There are differences we will discuss accordingly. So what are the specs we need? The specs we need is right here. There is an existing deployment. This is the name of the existing deployment right here in a namespace. And this is a spec number 1, 50% CPU usage per pod. So we need to put this value somewhere. We need to find that place. Next is this particular thing right here. 1 pod is the minimum and maximum is 4 pods. And the last one is the stabilization window, 30 seconds. So those are the specs we need for this particular object right here. Now, being said that, I'll ask you to pause the video and read the question yourself and see if you can answer the question yourself by doing research only inside the Kubernetes IO website where the official documentation is there. Now coming to the answer. So first we will look at the answer and we will execute the answer, and then we will see the reason for answer. So this is the YAML file for HPA, or horizontal pod autoscaler, and we have mentioned the namespace as well as the name of the deployment right here. So this is the first thing we need to mention, scale targeted ref. So horizontal pod autoscaler at the moment is targeting towards a particular deployment. And the next spec is max and min replicas, which is right here, 1 and 4, directly from the question. And then the CPU utilization. So when to autoscale. So this is also from the question. And then the final spec is the stabilization window in seconds. We'll give some more information in the reason for answer session, but otherwise for passing the exam, all you need to do is execute this particular YAML file using kubectl apply command, and you're done from the answer perspective. That's all you need. Of course, in the exam, these particular strings may be different. Definitely the namespace is not going to be sourcelength dev or sldev, so you need to change all those values. But otherwise, this is the answer to the first question pretty much. Now what we are going to do is we are going to the terminal and we are going to execute it, and we are going to explain what is horizontal pod autoscaler and a little more details about the answer. So this is the official documentation of HPA. So you can go to the kubernetes.io. This is accessible in the exam, and if you type HPA, you will get this particular page which you're in right now, as well as a second hit you will get this page as well. So it's like a walkthrough. Pretty much we will be following this walkthrough. Pretty much the answer is there in this particular page. Almost everything we need. Couple of things we have to take from the other pages as well. The one here. Let's have a quick look at the object first to construct the answer from the documentation. So this is one of the things we need. The utilization of CPU. We'll be putting this particular value to 60. And it is in this particular page. Another thing we will be using is the stabilization window. It is again in this particular page. So this is the first occurrence of an object like the one we need. Max replicas, min replicas, all these sort of things. And a couple of things we need to copy from the other page. This is how you refer it in the exam. So copy and paste this particular piece right here, and copy and paste a couple of things from this page which I showed you. Unless of course you remember these things in the exam. So that's how you construct your answer in the exam. I'm just showing you where exactly the things are. Now before getting into the demo, what exactly is an HPA or horizontal pod autoscaler? So let's get into the Blackboard and have a look into what it is. So we have our cluster here, the whole cluster, and we have our namespace within the cluster. This is the namespace we are going to deal with. And in the namespace, we have our deployment. This is the deployment we have. And by default, if you don't give HPA. What happens is you need to mention the number of replicas. Within the deployment, you have pods. These are the number of pods. So for example, in our case, we are going to test with a PHP Apache, but these are the number of pods. Pods are nothing but a unit of compute. You can think of like a lightweight container or virtual machine, in fact. It has IP address and things like that. But at the end of the day, you need to hard code in the deployment how many replicas or how many pods you want in your deployment. For example, in this case, it is 3. So we have 3 pods running with the exact same container workload. Now we have a service and we are running traffic to these pods. The traffic is coming to this port. And now there is a high CPU. There is a lot of traffic and we need to increase the number of pods dynamically based on the traffic. The CPU usage is 100% in all these pods. Now, in the absence of HPA, all the requests will fail or slow it down or something bad will happen because you have hard-coded 3 replicas in your deployment. Now, with the help of HPA, you're allowed to make a range, a min value and a max value, say 20. And you can mention when the CPU is above 50%, you start scaling the pod. So that's the idea. In that case, there'll be new pods coming up in the deployment. When the traffic is high, the memory utilization is high, whatever you are interested to monitor. Number of requests, whatever counter you want to mention, you can mention, and it'll auto scale horizontally. So there is something called vertical scaling. Vertical scaling is increasing the CPU usage of one particular pod or one particular compute. Horizontal scaling is increasing the number of compute itself. In this case, we are generating number of pods. Horizontal scaling as well as vertical scaling is a very general concept. Nothing tied to Kubernetes in specific. It is a very general concept. You can apply that for virtual machines, normal containers, everything. Horizontal scaling means you are replicating the existing compute resources horizontally by creating more number of virtual machines, more number of containers, in this case, more number of pods. Vertical scaling is increasing the CPU of one particular compute resource, increasing the CPU of something like RAM of a virtual machine or a pod or a CPU of a pod. Disk could be anything. Now, that's what we are going to try it out. We are going to start with a deployment with a service attached to it. And then we are going to load that particular instance of the deployment. And then we will see this particular HPA is working or not. And in the end, I'll be giving some inputs from my perspective, where it can be used and what are the shortcomings from an architectural perspective as well before the end of the lesson. Now, let's get in the demo and see this thing working. As I mentioned, our answer is based on this particular page and we will be kind of going through this page. So one thing we need for this HPA to work is a metrics server. So it is another deployment. So we need to deploy that. We don't have to do any of this thing for the exam. For the exam, the answer I have already given, just do that. I'm just showing you all these things so you can understand better about horizontal pod autoscaler. So we have a deployment here. This deployment is nothing but created from that page which I showed you, and it matches some of the aspects of that question, some of the names of that question. This name is coming from the page. I have not changed it. Just a PHP installation, PHP Apache. That's the installation. And there is a service which is getting created to expose this particular deployment. This is starting with one replica that is hard-coded. This is where the replica, the number of pods getting hard-coded here. This is the number of replica. I can put 100 here if I want, but the problem is it'll misuse the resources. I don't need 100 every now and then. Only when the traffic is high, I need to increase the number of resources. Otherwise, I'll be wasting the number of pods, wasting the CPU or memory or disk for that matter. So I'm starting with 1 and let's create this. I'm going to copy and paste. So I'm going to use Killer Coda Playgrounds. It's very useful for testing this. There is a paid version of it. I'll be using the free version of it. I really recommend, if you're really into testing things, you can purchase the Killer Coda Playground. I have no association with Killer Coda or Killer Coda Playground. It's just that it's good, but feel free to use any kind of playground or your own Kubernetes installation for this particular exercise. I'll be simply using Killer Coda. This is a URL for the Killer Coda playground in the Kubernetes. There are other Kubernetes installation, but I'll be using this one particular installation. And normally in the exam, what I do is I'm just going to keep YAMLs according to the name of the question or the number of the question. That's what normally I do. In this case, vi1.yaml, and I'm going to paste the deployment. Again, none of this thing is required for the exam. All these are there already created. I'm just showing you how horizontal port autoscaler works. Now I'm going to save it. Let's see if we can apply that. K apply -f. K is kubectl 1.yaml. It has worked. It has created a namespace, then a deployment and service. If you want, you can check the status of these things. But in my case, I'm going to continue with the rest of the installation. Now next is we need to install the metric server. I'll do one thing. I will not install the metric server so that you will understand what happens if you don't install. Now, this is the most important part, and this is what you need to do for the exam. Only this much. We have seen this. I'm going to copy the answer. So this is the answer. Again, 1.a.yaml. A for answer. Pretty much all these things we have discussed. If you have any questions, feel free to ask me. But otherwise, all the documentation I have provided, all I'm going to do is save this and continue. Again, I'm going to apply this. And this is the only step you need to do in the exam. So if you do these three things, you are done with that particular question in the exam. But otherwise, it is just explanation, everything else which I'm giving. Now, if you look at the port autoscaler, the horizontal port autoscaler, which we have created, as you can see here, there is unknown. So this is the existing or the current CPU usage. So this is a target. We have given that. This is the min port, max port, replica. So the current replica is 1 and 34 seconds. It has created 34 seconds before. And these are self-explanatory thing. So this value right here, the unknown, is very important, and it is coming from the metric server. So there is a little bit of work involved in installing the metric server. So first we need to go to the URL right here of the metric server deployment. This is the URL right here if you want to copy. Otherwise, simply you can search in Google for Kubernetes metric server and you should reach this particular page right here. Sometimes it changes. These URLs changes every now and then. So feel free to do your research if you're watching this after a long time. I'm going to copy that and paste it here to install the metric server. So in this case, I'm going to check the health of the metric server. So the command is kubectl get pods -n kube system. So the pods are normally coming in the kube system namespace, the metric server. As you can see, it is erroring out. It is not working. Let's try anything better happening inside our horizontal pod autoscaler. Nothing better is happening in our autoscaler. It is still unknown because this thing is not working. The reason this thing is not working is because the kubelet doesn't have a proper certificate. And if you don't understand what that means, don't worry. I'm going to fix this right away, this particular problem. So the command is kubectl edit deployment -n kube system metrics -server. So we are going to edit that particular deployment. So why we are going to edit? The reason we are going to edit is that because of the issue I mentioned, we need to add an additional parameter to the argument. So this is there in the documentation of metric server if you want to do it yourself. Now what I'm going to do is that I'm going to copy that particular command and paste it here. So this is where I need to change to fix that. Now, if you have seen my security training, you will know exactly what it is without any additional information. Now, if I'm going to explain what this particular argument means, it is not going to work as well because you may not have the right background. Otherwise, you know what this is. It is clearly saying insecure TLS. You're asking to trust the default certificate given by a web server. That's all about it. It's a very common solution when you don't have a proper certificate in one of the targets. But otherwise, I'm not going to give any more explanation on this. All it is going to do is confuse. So I'm going to write and quit. Now I will wait for that particular port to come up. As you can see, there's a new port has created. Both are not running. So both has to be in the running state. In fact, one of them has to die and the other one has to come up. If you want, you can do a watch on this. Now, as you can see, it is a running state. Let's see if your horizontal port autoscaler is in any better shape. So this is the command. By the way, this command is a lazy way of doing it. Let me type that. CKA-HPA-N SLDev. So this is the right way to do it. You can do the way I did if you want, especially in the exam for that matter, because you don't have to type all these things, but this is the more readable way to look at it. As you can see, that unknown has gone and one person has come up because our metric server is running. Now, what is next? The next thing we're going to do is we're going to load this thing up and see if it is scaling. That's what we are going to do next. How do we do that? For that, we need to come back to this particular tutorial, and there's a command they have given, and we're going to use that command from here. So we need to modify a little bit. For example, we need to put this particular command into our namespace. Another thing I'm going to do is I'm going to load a bit more than this. Don't worry if you don't understand any of these things. This is just loading to increase the CPU usage. One of the things we need to do is there's a blocking command. So we need to create another terminal. So this is another terminal. This is why I like this Killer Coda playground. It has a lot of features. You can have an editor and things like that. For example, if you want to look at the file and things like that. So this is a file we have created. It's like a Visual Studio Code kind of interface right here. And you can edit that file as well. So these are the files we have created. It's very useful that way. I really recommend. And if you have the option to pay for it, go for it. I really recommend that as well. Now coming back, I'm going to execute that command. So this is the command which I mentioned. The same command, only thing I have added is this namespace right here and then a little more load. Depends on the CPU and things like that. We may get a chance of running the same thing in another terminal, but we will keep a watch. So what we're going to watch, we are going to watch this particular thing right here. Watch this command right here. As you can see, the CPU has gone up and the replica is already 2 from 1. It is already scaled up. It happens pretty quick in seconds normally. Depends on how much CPU, how much is the load and things like that. Sometimes you may have to run it a couple of times, but in the case I had to run it just once. As you can see, when the replica became 2, the CPU load is coming down. Now if you want to increase the load further, you can try the command again and load it more or that kind of things. You can play around this thing a little bit. You need to change the container name if you are running it again to load it more. Otherwise it will say the container exists. So there is one more bumping happening to that particular service. As you can see, the CPU is growing, being 40 from 38. Now it has gone up again. Now I'm expecting one more port to come up. As you can see, it became 3 right here. Now this will go down because the traffic has been stable and the port has increased. As you can see, it is coming down. So it is working exactly as it is designed. So this is the working of horizontal port autoscaler. Now, in huge workload scenarios, this may not really work because at the end of the day, you are limited by the underlying nodes. What you need to do is you need to use something like Carpenter or node scaling technology. There are a lot of ways to scale your nodes in the cloud. Node scaling is harder than it is, especially if you're not on cloud. Node scaling is a very difficult activity, especially in on-prem. But there are ways to get around it. But in the real world, in the real load, like millions and billions of request scenarios, this may not solve your problem. But in small issues, small workloads, small scaling scenarios, this will be fine. Otherwise, you will be limited with the number of nodes behind it. One thing you can do to make most of the horizontal port autoscaler is making your cluster as big as possible and share between so many different applications so that you will have a lot of wiggle room. But at the end of the day, a lot of the organizations which I have worked, they don't do that. They have like one cluster per application, which is the wrong thing to do. It's a waste of resources. So that is the final point I want to mention about the horizontal port autoscaler. And the answer is pretty straightforward. Just give the YAML we have seen and just done with the answer and move forward. So this is the answer to the question.